Hello, and welcome to a quick lesson on how to use the PhET Circuit Simulator. One, to just study circuits a little bit, and two, specifically to get the job done when it comes to doing your Ohm's Law lab. So, if we use the link from the syllabus or from Schoology, we should get a page like this, and we want to choose Lab, and it'll give us this workspace. Now, both the instructions in the lab and our notes, they tell us that every circuit needs a couple basic things. You need a charge pump that adds energy, so a battery, a power source. Um, we need something that resists the flow. So a light bulb or a resistor, both of these things do it, but we're going to choose resistor because that lets us control the resistance. And then we need wire that connects the ends of our things to create a continuous loop. So we have our power source, we have our resistance, and in this lab, all we have to do is drag these ends together, and you can see that we get a circuit that has a charge flowing around it. Now, unfortunately, this circuit does not have the equipment that we need in order to take our measurements. So here's a basic circuit. We can see that electrons are going one way around it, or we can change the setting so that it's conventional current. Conventional current was saying that positive charges flow. We know that positive charges don't actually move around. Protons are not flying through the wires here. We know that, in fact, it's electrons, but the math works out the same either way. And so when we set this up, we didn't really know everything about electrons. So we define current as being positive charge going around. It doesn't really matter which one you use in this simulation. So I'm going to leave it on our positive current. Now, we wanted to get readings though. So I'm going to select one of the intersections in here, and I'm going to insert an ammeter. And we want to do this type of ammeter, the one that goes into the circuit. In the notes, it says we need to break the circuit and make the ammeter part of the loop. And honestly, when you follow the instructions for the lab and you play around with some of this stuff later, you'll see why the ammeter needs to be part of a single loop. It's basically like a piece of wire that tells you how much current is flowing. So now we actually have a measure. I'm going to show you how to use one other thing, though it's not strictly necessary here. I'm going to pull out the voltmeter, and I'm going to touch the voltmeter to both sides of my resistor. So I'm taking the voltmeter and just taking these wires, and the voltmeter is just set up in a way that it's touching both ends of our resistor and tells us what the voltage drop is across there. Now, I haven't done anything to control the voltage input or the resistance, so we're going to check the instructions real quick and before we start collecting data. So if I look at my lab page, it says we want a voltage of 5 volts and a resistance of 10 ohms. And so in this simulator, we can just click on the battery and we can actually control our number of volts, our potential difference. So if I move my slider so that the battery is providing 5 volts, that's pushing the current through here. Similarly, we can control the resistance in this case. Normally, we'd have to change out the resistor in a real circuit, but each resistor has one resistance, but our nice magical simulator has a resistance that we can control. We can set it. So I'm going to double check again. 5 volts, 10 ohms, 10 ohms of resistance, and 5 volts on my battery. Okay, well then I'm set up where I can record my data for my current. After this, we can change our voltage and our resistance accordingly and fill in the rest of our data table and then answer the questions that are asked on the workbook page. try playing around with this. This simulator is good not just for this lab, but for later on practicing just setting up circuits. This is a thing that you can use anytime. So we're pretty fond of this simulator because it's nice to be able to have a place where you can practice without any risk of starting a fire. All right. So enjoy, and I hope you have a good time in the circuits unit. Take care.